this is Josh White with JW Math Tutoring. In this video, I'm going to cover the ultimate Desmos guide to digital ACT math intermediate skills. So let's go ahead and take a look.
But life is a dream the calculus could never predict.
Before I start this ACT math video, I just want to take a couple seconds and let you know about my Improve Your ACT Math Score course, available on both Udemy and Teachable. The course features a wide and comprehensive review of ACT math topics, including how to use both the TI-84 and Desmos graphing calculators. It also includes general strategies, such as backsolving and picking numbers, and a review of topics in algebra, geometry, probability and statistics, and other miscellaneous topics as well. It includes over 10 hours of instructional videos and over 20 total hours of videos including solutions to various problems. So please check out that video if you're looking for more help on improving your ACT math score. Otherwise, if you like this video, please do give it a thumbs up, subscribe to my channel, and sign up for notifications. And let's go ahead and get started with this video. Welcome to part 4 of my Ultimate Desmos Guide to Digital ACT Math. This video is going to cover some intermediate level skills in Desmos. These are other skills that are a bit more complex or a bit more advanced than those covered in the previous video, the core skills, or the topics that they deal with and cover are a bit more advanced or complex than the topics that were covered in the core skills video, even if the actual operations themselves are not. All right, so let's go ahead and get started. But first, I do want to mention there is a link to a PDF copy of this reference sheet that what you currently see on the screen now in the description of the video and also in the pinned comment. There is also a link to a PDF file of the problems that I'm going to go through in this video and the other videos as well, in both the description and in the pinned comment. Also, the website that I'm using, which is basically the web version of the Desmos that is featured on the online or digital ACT, is listed at the bottom of the screen. So if you're doing, paper problems, this is the website that you should use so that it basically mimics the ACT version of Desmos. And other than that, be sure to check out the other videos, in this guide if you haven't done so already. All right, so let's go ahead and get started with the first topic at the top here. Identifying equivalent expressions, or this general process is also going to be used to solve a single linear inequality. So what I'm going to do here is talk about the two methods that you can use and then show you basically examples of each. Now, I briefly kind of used this technique towards the very end of the last video on one of the problems that dealt with translations and shifts of graphs. But basically the idea is if you graph an expression and then you graph other expressions to try to find out which one is equivalent to it, the one that's equivalent is going to overlap the original expression completely. Okay? If it does not, if the two expressions do not overlap completely, then they are not identical. They are not equivalent. You typically use this when you have expressions that either only have an x or only have a y, or maybe have like some combination of x and y. Sometimes also for expressions that have x's and y's in them, you may need to actually turn it into an equation. I mean, you might need to set it equal to some number. Just set it equal to 0, set it equal to 1, doesn't matter. And this graphing method can also be used to solve inequalities, where basically you would essentially type in the original single linear inequality. Then you would type in your answer choices, and you would see, which ones overlap completely with the shading. All right, so that's just a brief overview of the graphing method. Now, there's also the numerical method where you can take the original expression, say, that you're given, and you can basically pick numbers for all the letters or variables or constants in it. And so the way you would do that is you would essentially, type sliders for the various letters, and then you're going to type each of the answer choices, and you're going to see which one returns the same value as the original expression does. Essentially which one matches it. One thing just to be aware, if you're going to use this approach, you can't use lowercase x or y. Instead, you would technically have to use x1 or y1 with a subscript, okay? Or you obviously could also just use capital X or capital Y if you really wanted to use those letters instead. Okay, so now let's go ahead and take a look at some problems. All right, so we're going to start here with problem number 22. We left off with 21 at the core skills video. We're picking up here with number 22. So here you basically have two rational expressions that are being subtracted, and it wants to know what do you get when you go ahead and work this out. So for this approach, all we're going to do is, I'm going to show the graphing approach first. Graph out, the exact original expression you're given. Then we're going to go through the answer choices, and we are going to see if they overlap. Okay, this one does not overlap, therefore it is not the correct answer. Okay, so I could just go ahead and cross this out. All right, now if I want to check the next one, notice all I need to change is the denominator on the bottom. Okay, notice these two graphs do not overlap, really at all. Therefore, that is not going to be the correct answer. And then we have 2 to check here at the end. So either one of them is going to be correct, and that's either if the first one's correct, that is our answer, or if it's not, then it's the other one by process of elimination. Okay, so let's go ahead and type the first one, and down here. Now I do need to remember to put the minus sign in front. Okay, so these two are pretty close, but it's not a complete overlap. So it looks like it's going to be D by process of elimination. So let me get rid of this, and let me change this. And now you can see there is only one graph visible on the screen because they are overlapping each other. So the correct answer for this problem is going to be letter D. And now I'll just show you briefly how you could also do this problem using the numerical value approach. So if you wanted to keep it x, just keep consistent with the problem, what I would do is I would first change these to x1. And then I would just say, let's let x1 equal. Now here's where you have to be careful because you cannot make it a number which would, in this case, give a 0 in a denominator. So let's just make x1 equal 10. All right? So we've done that. That's our slider that I just added. Now, if I add an x1 to all of these, it's going to turn it from a graph into a number. Notice I get the exact same value, 0.1775363, blah, blah, blah. Okay, so that tells me this is the correct answer. And if we went through all of the other ones, you would see they would not have the same value. So a couple things to keep in mind. The graphing approach can only be used in certain cases, whereas the numerical approach, we can pretty much use in any case. All right, so let's look now at another example problem, number 23, top of the next page. So for this one, what I'm going to do, first I need to get a 6th root. So hopefully you type nth root if you watched my Introduction to Desmos series. And then since I have a fraction, I'm just going to hit the division sign first. Then we do x to the 8th, y to the 12th, and then z to the 2nd. Actually, I will zoom in also just so it's a little bit larger, a little bit easier to see on the screen here. Okay, so notice this is not graphing, right? This is trying to find an equal sign. Oh, and that's not supposed to be x, it's supposed to be z. See, now it's not only is it not graphing, but it's also asking for a slider. All right, so I'm going to take this one, I'm going to have to use the numerical approach on. I mean, I guess technically you could try to add a value for z and then set it equal to something and try to graph it, but I'm just going to use the numerical approach on this one. So I'm going to add subscripts for x and y, not for z though. Okay? So notice the default is 1, but we don't want that because we're most likely just going to get 1 for all the answer choices, and then they're all going to be the same, and that doesn't really tell us anything. So let's move this to wherever. Let's just throw this to wherever. Let's throw this to wherever. Okay, perfect. Now I'm going to type the answer choices. And remember, you're going to have to type x1 and y1. Now I need a cube root. And then underneath it I have x1 over z. Okay, so notice for this problem, it looks like this is the correct answer for answer choice A that I get right away. So let's keep that. I'll just check the other ones to make sure. All right, so it looks like for answer choice B, I need to get rid of this squared. So notice when I do that, I do not have the correct answer. I've got 12.668 something, not 32 whatever. All right, and now for answer choice C, basically I get rid of this and I move this y inside, not the correct answer. And then for answer choice D, now I've got the y1 squared back outside, but no x1. Okay, it's not correct. Therefore, the correct answer here was the first one I checked, letter A. And again, the way I equated these two expressions was using basically the numerical method or the number method. All right, let me zoom back out. And let's look at another problem that you could use this on. So here we have some expressions, polynomials really, that are being added. And I'm just going to type in the original expression first. Okay, so notice it's not graphing anything, right? It's giving an error here. Try trying. So if you want to use the graphing approach on this, technically what you have to do is you have to set it equal to 0 or some number. Now, did we actually get anything here? No. Okay, let's set it equal to 10. Did we get anything? 100, 200. Oh, I'm zoomed way out. Sorry. Let me zoom back in. Okay. Here, let's set it equal to 10. Okay, notice we get this weird looking kind of slanted ellipse right here. So now, we can go ahead, use the graphing approach. On this one, we just need to set it equal to the same value, right? Because they're equivalent, and the first one's equal to 10, then the second one also has to be equal to 10. All right, so correct answer is not A. Let's check B. Yes, notice these two now overlap completely, therefore they are equivalent. Again, a lot of you could probably just do this problem, in your head, combining like terms, and that's fine. You don't need to use Desmos for this. This is just showing you an option or that you might want to use when there is a much more complicated problem. But the correct answer for this one is just going to be letter B. I mean, you could go ahead again and you could try out C and D, but here we notice that letter B matches the original expression completely. All right, so let's try one more of these. So I'm going to show you later in this video. Actually, no, I think it's in the advanced skills video, how to use regression to do a problem similar to this. But one way you can do a problem like this is by matching equivalent expressions. So what I'm going to do is the following. I am just going to go through and type each graph. Now, another little tip is if you're trying to type a fraction or an exponent that has multiple terms, if I try to type +2, it's going to default down to the main level. It's not going to say in the exponent. So really what I should do is I should type like +2 first and then go back and put the x in if I'm going to do that. Okay, so here is the first graph. Does this match the graph on the screen? And again, I'll zoom in here so we can see the points a little bit better. Okay, it obviously doesn't. It's going the wrong direction. It's a decreasing exponential. We want it increasing. Okay, so now let's go and let's check answer choice 2. Okay, does this one match? Well, it looks pretty similar, But what we need to check is some points on the graph here. Okay, so we've got 0, 3, we've got 1, 7, and we've got -2, 0. Okay, so those are all points that have integer values for them. So 0, 3 right here, yes. -2, 0 right here, yes. Is it at 1, 7? I mean, you can trace along here, or you could graph x equals 1 and see if it's at 7, or y equals 7 and see if it's at 1. Or you could do a table and you could just type in, 0, -2, 0, 1 and see what the y values are. But this is going to be the correct answer. You can see if you check the others. So notice this one, this is answer choice C right here. Notice this one crosses the x-axis at a positive value, but the graph crosses at a negative. Okay, so that's obviously not correct. So now let's check answer choice D. Okay, this one you can see it looks like it goes much further below the x-axis, and also you can see, like right here, it's crossing at 0, 1. This graph is not crossing at 0, 1, and it's crossing at like -0.41504 on the axis, where this is at -2. So that's obviously wrong. Okay, so for this problem, again, the correct answer is just B, and I was able to basically graph each of these and then see which one matched the original graph that I was given. All right, now here's how you can use this same basic approach or same basic technique to solve some inequalities. So first up we have number 26 here, a basic linear inequality, right? So all I'm going to do is type in the original given problem. Okay, and notice I get a vertical line here shaded to the right. So now I'm just going to go through each answer choice, and one of them should match it completely. Okay, it looks like it is this one. Notice, the overlaps completely. Let's check B. Okay, that is not the correct answer. Notice it's not overlapping. It's actually on the opposite side. Okay, let's check. Oh, that was actually D that I just checked. But let's check C. X is greater than or equal to 11/5. Notice there is some overlap, but it's not completely overlapping. Like it starts over at 2.2 instead of over here at 5.5. So that's obviously not it. And then if I flip it the other direction, get rid of this. Okay, notice again, it's not overlapping. That's wrong. So we can clearly see here the correct answer is going to be letter A. And so for a single linear inequality, this is how you can basically solve it by essentially matching equivalent expressions in Desmos. All right, now let's look at the one below it, number 27. This one is a compound, or basically a double inequality. Now, the thing is, you cannot just type it as one full statement like this. See, it's giving me an error. It's not graphing anything. They don't support solved double inequalities. So what you have to do is you basically have to type like just the left half, meaning the -10 up to the -4 to get one inequality, and then you would type the right half, which is the 2x minus 4 less than or equal to 4. The solution is the part in the middle, okay? So we want like this dark part in the middle between -3 and +4. Now, if you want to, you can probably just look at the answer choices and realize that it's going to be B. You know what I'm saying? Like you can just see, oh, x is between -3 and +4. Therefore, the correct answer is letter D. However, you could also check the answers in Desmos. Now, it's going to take a little work because technically, again, you do have to graph each of them separately. So, like, basically, it's a little tricky to see here, but if you graph this one, notice there is like some overlap here that is not in the original, basically solution set. So this one is going, and same thing here, this one is going to be incorrect. I mean, this part matches up perfectly. It's this part that doesn't match up perfectly. It's this part where there's shading in here, where there shouldn't. where there should not be. Okay, so now, or sorry, let me backtrack on that. The problem, the issue, let me explain this better. The problem or the issue is that this whole region right here is not shaded or not like overlapped. That's the problem or the issue. This is overlapped in here, and and this is correct. That's what we want. It's this region over here on the left that is shaded from the first inequality, but not the second. Okay, and then you could go through and you could check some of the others. And I'm not gonna bother like checking all of them. I'll just go back to the correct one and just show you. So notice here, essentially, you could also look at each one individually. You know what I'm saying? Like, notice these two overlap completely. I think this is the easier way to do it. These two overlap completely. And then let's turn those off, and let's look at the other parts. Let's look at the less than things. Notice these two overlap completely as well. So that's how we could tell that, again, D is going to be the correct answer. All right, so now let's go back to the guide. Let's talk about solving formulas. Okay, so there are actually multiple ways that you can solve a formula, but the method that I've settled on, what I think is the quickest and easiest and simplest, is to just basically take the formula, type it as a regression statement, meaning you're going to take the thing that you're given, but you're just going to put a tilde in there, and for any x's or y's, you're going to make them x1 and y1. Then you're going to type the answer choices, and you're going to see which one of the answers has the same numerical value as the original expressions. Now, one thing to keep in mind is you may need to pick values for some of these letters using a slider if you're getting more than one answer is correct, or if for some reason it's not giving you values that meet the conditions of the problem. Like if something is supposed to be positive and it's giving you a negative value, or supposed to be greater than 5 and it's, a number less than 5, and vice versa. Okay, so let's go now back to the worksheet. So let's look at a problem here at the top of this next page, number 28. All right, so here is a formula. A plus BC squared equals BD. So what I would do is I would type this out, use a tilde. Okay, notice it assigns values to all the numbers, but the problem is it's making A equal to 0. That is bad because it tells us that A is non-zero. So I'm going to make A 1.2. Okay, now notice it's given me like random value, or not one, whatever. It said 1.2, but I actually typed 1/2. So whatever, we'll go with 1/2 because that works. Now, notice it's giving me different values for B, C, and D. Okay, this is perfect. So, which of the following is equal to C? So, in the regression statement, C is 0.60008. So I'm going to type all of these expressions, and I'm going to see, do I get the exact same value right here, as my, the value for my formula? So for the first one, I do. So it looks like that's the correct answer. Let's go through and just check the others to make sure. Okay, B does not match. That is wrong. Let's check D minus. Okay, C does not match. That's wrong. And D does not match. That's wrong. So the correct answer is answer choice A, and that is how you can quickly and easily solve, any formula for a specific letter in Desmos. All right, let's look at another example here. Number 29, solving this one for y. Clear this out. Now, again, if you have x's and stuff or y's, lowercases, you've got to change them to x1 and y1. All right, this one again, it gave a bunch of 1s. I don't know why it did that, so I'm just going to say let's add x1 equal. Now I'll use 1.2. Okay, now it's, so notice it actually made it worse. For some reason, it's giving everything as a 0. So, okay, let's make z 0.6. Okay, it's still trying to make, so let's instead look at w. Okay, and now See, some of these, for some reason, it takes, a lot of manipulating to actually get it to work. Let's make z equal to 0.8. All right, now we have actual, like, non-zero values for all these things, right? I mean, you can pick, like, I picked numbers for x, w, and z, and then it just determined what y had to be. So now, let's just check our formulas. Okay, the first one is equal to 4.36 repeating. Is that 3.88333? No, that's wrong. All right, let's check B. W plus Z over X1. Okay, 3.75. No, close, but not correct. And we have WX plus Z. Okay, 3.88 and then a bunch of threes. This one looks like it is correct. Let's just check D to make sure. 2.23. Nope, it's wrong. So the correct answer for this one is going to be letter C. Number 29, solving this formula. All right, let's go back to the guide now. We'll talk about the next topic, which is permutations and combinations. So, if you learned permutations and combinations, this is just basically the shortcut to get the actual value, not needing to, say, memorize the formula or, do it out by, like, obviously, write out the hand with the factorials and all that stuff. So all you're going to do is you're going to type n, a capital PR, and then inside the parentheses, you're going to type the two numbers, basically the n number first, the number of objects, and then the r number, the number that you're choosing from the total. Or for combination, NCR. Okay? So this is just showing you how to do these formulas. If you have never heard of permutations and combinations, or not sure what they are, then essentially you can just ignore this or go learn about them, research them somewhere else. Okay, so number 30 here. Here we have a problem. A bookshelf can hold 6 books. There's 12 total books that John has that he can place there. How many different ways can he arrange the books on his shelf? This is a permutation because the order of the books matters. Which one is first versus second versus third versus fourth, so on. So basically what we're doing here is just 12p6. That's it. So we just go to Desmos and we type NPR and then parentheses 12 comma 6, and there's our answer. 665,280. So the correct answer for this one is going to be letter C. And that's it. Now, if we look at the next one, number 31, here you have 75 people and you're making a committee with 3 people. This is going to be a combination because the order that you choose the people from, or the order, that you choose the people in, does not matter. It only matters what 3 people are on the committee. There aren't like specific positions that are being filled. It's just 3 total people on a committee. All right, so all we have to do is go to Desmos, and now we can just type in NCR 75 comma 3. And we get our answer, 67,525. So the correct answer to this problem is also letter C. One last thing just to mention or be aware of. They have had problems, the ACT has, in the past, where the answer choices were not values like you see here, but they were expressions with factorials, meaning they were doing like the permutation and combination formulas. They were giving you those as the answer choices. If that happens, all you have to do is go ahead and just type each answer choice in with the factorial, and it'll go ahead and calculate it. Okay, so just to show you what I mean, for number 30, the correct answer is basically, it's really 12 factorial over 12 minus 6 factorial, but 12 minus 6 is 6. So like, for example, I mean, it could be listed like this, or if they listed it like, for example, like this in the answer choice, you just type it in with the exclamation point, and then you see which of the answer choices matches the value I got when I did the permutation up here. Okay, so just something else to be aware of. All right, now we can go back to the guide. We can talk a little bit about factoring, and basically factoring polynomials. So the whole idea is, if you have a graph of a polynomial, if you look at the x-intercepts, you take each x-intercept and you make a factor from it by doing, x minus that number. Okay, so if the x-intercept is 9, that means the factor is x minus 9. If the x-intercept is negative 3, the factor is x plus 3, because it's x minus negative 3, but the two negatives cancel and make it positive. So that's the whole idea. All right, so now just look at a basic example. And again, most of you probably looking at this can just factor this in your head. You don't need to use, Desmos to do this, but this is just to demonstrate, the technique and how you could use it. And, if you needed to use it on a more advanced or a more difficult problem. So what you would do is x squared minus 5x minus 36. Okay? And let me just slide this over here. So here are my factors. I'm going to export this, export this. Okay. So again, each factor is, and let me get rid of this, it's x minus the intercept value. So that's one of them. Then the other one's going to be x minus the intercept value, which is 9. So two things. First of all, the correct answer here, these two minuses, I'll just make a plus, is going to be x plus 4 and x minus 9. So it's going to be letter B. So that, first of all, that in general is how you could factor an expression. But I also do want to mention that if you were solving a problem like this, you could also use the equivalent expressions technique, which is, you have the original expression, and you just run through the answer choices, and you see which one overlaps completely. That should be, sorry, minus 4. Okay. So like, for example, here's answer choice A, not the same as the original expression. Here's answer choice B, yes, is the same as the original expression. One other thing just to mention. Let's say you end up with a problem like this. Okay, so we have two intercepts here. Okay, so we've got positive 2. All right, that means we have a factor of x minus 2. Now the other one is x minus negative 1.5. However, two things. First, I'll just make this into a plus. Second, okay, notice it's not overlapping completely. So really what you have to do here is you have to first, like, you turn this into 3/2. You think about it as a fraction instead of a decimal. And then what you have to do is you basically have to get rid of the fractions and turn this into a whole number. So what I mean by that is, if you have x plus 3/2, you basically multiply by 2, and that really turns it into 2x plus 3. And that is the actual factor. And now if I go back here, what you're going to see is that when I change this to 2x plus 3, the graph will overlap it completely. So notice now it overlaps, meaning that, like, yes, this is the correct factorization. So that's what you have to do if you have a decimal x-intercept value. You basically have to multiply every term in that factor by whatever the denominator is to cancel out the denominator and turn the second term into an integer value. All right, now we'll go back to the guide to look at our next topic, which is finding the mean of a data set that's given in a frequency table. So this does not come up very often, but it's still something good to know, because you can also use this same basic process if you have an expected value problem to complete. The basic idea is you make a table, you enter the values in the x1 column, you enter the frequencies in the y1 column, and then you type what you see on the screen here. This total x1 times y1 divided by total y1. That will give you the mean of the data that's in a frequency table. So here's an example. So first column we have the number of birds that were seen, and on the second column we have the number of the days that they occurred on. All right, so now all I'm going to do is just type in various values. And then I'm just going to type total. Actually, you know, I'm going to do the division sign first. Total x1 times y1. What that does is it basically goes across each row and it multiplies the x value by the y value. And then the total function sums them all up. So it multiplies across and then it sums all the values together. And then it's going to divide that by total of y1. That's just the total of going down the y1 column. Now, notice it doesn't come out exactly to an integer value. Well, the question says, you know, what's the mean number rounded to the nearest whole number? So this 29.07 would just be rounded to 29. The correct answer for this is going to be letter B. One other thing to mention. There is no easy or simple way to find the median of a data set when it's provided in a frequency table. Like I talked about the median, finding the median back in the core skills video, but if the data is in a frequency table like this, there's no easy way to find the median. There is a way to do it, but it's like really complicated. You know, it's not worth learning. That is instead something that you can do very easily on a graphing calculator, a physical graphing calculator, like a TI-84 or TI-Nspire. So just be aware of that. That will be talked about in a later part of this guide where I compare advantages and disadvantages for the TI-84 versus Desmos, you know, on the exam. All right, so now let's go back to the guide and talk about arithmetic sequences. So this is actually a common topic that still, you know, appears quite frequently. So basically, an arithmetic sequence is really just a linear function. It's really just like a line where the term number is like your x value or your input, and the number in your sequence is your y value or your output. So all you're going to do is essentially, if you have problems with arithmetic sequences, you just take what the values that you're given, you enter them in a table and basically do linear regression. And then based on what you're asked to find, you might need to do something, you know, beyond that. But the slope of your line, you know, your m value, that is the common difference, i.e. the number that you add to get from like term 1 to term 2 to term 3 to term 4 throughout the entire sequence. All right, so let's take a look at some problems now. First up, we have number 34 at the bottom of the page here. So for this problem, you are given that the third term is 3/4 in a arithmetic sequence, and the sixth term is -3/2. What is the value of the 10th term? Okay, you're going to be amazed at how quickly and easily I can do this in Desmos. Okay, third term is 3/4. Sixth term is -3/2. Now, you can just click the linear regression button, or you can type y1 tilde mx1 plus b. So like, for example, you could just have manually typed this instead of going through the work I did. But here we have the slope right here. This is your common difference. Here we have 3. That's the y-intercept of the line. But we're not concerned about that for these purposes. What's the value of the 10th term? Okay, so there's multiple ways you could do this. You could do x equals 10, and then you could see where does it intersect. Okay, so it's going to be negative 4.5. If you don't know what that's equal to, just go over here, click the fraction button. It is -9/2. The correct answer for this problem is letter D. You could also, by the way, instead of just graphing x equals 10, you could also have like plugged basically 10 back into the function. So you could set m times 10 plus b. And it would also give you -4.5. And you click this, -9/2. Notice this will only work if you have the actual regression statement typed. Meaning, if you only click the button like this, right? And then you try to type m times 10 plus b, notice it's not doing anything, okay? Because the values aren't defined as m and b just yet. You have to technically click this, or like if I get rid of this, or again, you can just type this originally from the start, and then you could type the 10 times m plus b. Okay, so now let's continue. Top of the next page. Here is another arithmetic sequence problem. Let me clear this out. Here you're given the first four terms, and they want to know what is the formula for any given term here. Okay, so a couple things. I would make a table, and you only really need to type two of these. But whatever, we can put them all in. That's fine. And then we're going to do linear regression. And we get negative 6x plus 10. Okay? So therefore, correct answer is A. That's it. And you can also see, I mean, you can also confirm this by looking at it, that to get from here to here, you're subtracting 6. To get from here to here, you're subtracting 6. To get from here to here, you're subtracting 6. So the common difference is 6, right? That means that this one and this one are out right away. Now what you have to be careful with here is the first term is 4. But technically the 10 here, the y-intercept, like that's the value you would get if n equals 0. That's like, you know, say a sub 0, which doesn't really exist for arithmetic sequence purposes. But it's not, you know what I mean? It's not going to be, if you plugged, in other words, if you plug n equal 1 in down here, you know, for a sub 1, you would get negative 6 times 1 plus 4. Negative 6 plus 4 is negative 2. Notice that doesn't match the 4 that we expect to get for a sub 1, okay? So that's just confirming that, yes, A is correct for this problem. All right, let's talk about the last topic now on this intermediate skills video, and that is finding the maximum or minimum value of an expression. Okay, so there's technically two different types of problems that this could be used for. The first type, which is actually the like really easier, kind of pretty basic type, is you just graph the function out, you look for the highest or lowest value. Usually it's on a quadratic function, you just look for the vertex, and you just take the y value and that's it. That's not really what's described here. What's talked about here is a second type of problem, which we're also going to look at, where you are given some expression with letters or variables in it, and you're told some type of values for those variables, meaning they're between some values or some numbers or whatever, and it says like, what's the highest or lowest, or the maximum or minimum possible value for this expression? Okay, and essentially to solve that type of problem, you are going to type in the original expression, you're going to add the sliders for each letter, and then you're going to move the sliders around and see, okay, when I move this to the right, when I make this bigger, does the expression get bigger or smaller? And then based on what the problem's asking for, you're either going to move it all the way to the right or all the way to the left. And you know, you do that until you figure out what gives you either the highest or lowest value. One thing to just be aware of, again, if there's x's or y's in it, you must use x1 or y1. If you're using lowercase letters, you could, of course, use capital X or capital Y. All right, let's look at some problems now. So first we have 36 here. So this is a real, you know, again, this is kind of like a real basic problem. You have this expression, and it wants to know, okay, how many acres of land are sold to earn the maximum amount of profit? So notice here, acres is the x or the input. So I'm going to graph this function out. I'm going to look for the maximum value, which occurs right here at the vertex. I want the x coordinate because that's the amount of land. So 13 is the answer. Correct answer for this one is letter B. If it asked for the maximum amount of profit, then your answer would be letter D, you know, the 375. Or, I mean, it's technically 375,000, but in this case, just, you know, 375. So that's it. Just graph the function, look for the highest or lowest point is, and then, you know, pick out whichever coordinate corresponds to what it's asking for. Now let's look next at number 37. So this is the second type I was talking about. You have this expression, okay, and I'm going to type it out. Now, I'm just going to start with like the smallest value for each. And then I'm going to adjust them and see what happens. There we go. Okay. Okay, I want the smallest possible value. So, notice as I move, so right now x1 is at it's at 1, okay? And x is between 1 and 5. So as I move this to 5, does the number get smaller? No, the number gets larger. So for the smallest possible value, I want x to be at 1, the smallest it can be according to the problem. All right? So that part is checked off. Now let's check y. It's at 5, which is the smallest value. Now as I increase to 10, does the number get larger or smaller? It also gets larger. Therefore, I need y to be in the smallest value, acceptable value as well, which is 5. Notice also that you could most of you can probably realize this, that if you want, the x's and y's are in the numerator, right? If you want the smallest possible value here, you want the smallest number on the top, and you want the largest number on the bottom, or in the denominator. Therefore, we want the smallest values for x and y, and then you're going to see for z, I started at 10, now I got to go up to 15, so let's do this. Notice, as I increase it, do the numbers get smaller? Yes, they do. They're now under 2. So therefore, I want the largest possible value for z, which is 15. Now, what's the smallest possible value of this expression? Well, it's 1.666667. Is that one of the answer choices? Well, no, it's in fraction form, so we just click this. Okay, it's going to be 5/3. So the correct answer for this problem is going to be letter D. And again, the general approach here is you're typing in the expression, then you're setting the sliders for each of the letters, and then you're moving them to see what happens to the overall expression value. Does it get larger or does it get smaller? You know, let's say you increase them or decrease them, and then deciding which end of the range each of them needs to be at based on what the problem is asking for. I hope you enjoyed this ACT math related video. If you did, please give it a thumbs up, subscribe to my channel, and sign up for notifications. Also, if you're looking for more practice in improving your ACT math score, please check out my course, Improve Your ACT Math Score, on both Teachable and Udemy. There are direct links to the course on both sites listed in the description and pinned comment of the video. Otherwise, good luck as you're preparing for the ACT math test.